Now this chapter, a lot of terms you need to understand, and we just need to know the meaning of all the terms in order to solve the question. Okay? Now, what is binary operation first of all? For this binary, you already know, it is what binary means 2, right? So the binary operation means we do the operation using 2 numbers. Okay? And what are the operator? Just like the normal operator that you do normally, plus, minus, multiply, divide, and also including all the operator for set, union, intersection, logical, connective, or, and so on. Okay, so whatever you have learned in your discrete mathematics operator, you can use it under this operation. Now, when can we say that the binary operation is valid? If, let's say, I give you a set of integer, okay? A set of integer. A set of integer means you have all the numbers, let's say 3 plus 4, the operator is plus, and you have integer with the operator plus. If I take any 2 integers and I add up together, I will get the answer is 7, which means this is also from the integer, right? Okay? Then in this case, if after the operator you have and the number you get from the set given, which is integer, the answer you get after the operator also integer, then we will say that the set given with the operator plus is a valid binary operation. It is a valid binary operation in this case because the answer after we do with any 2 numbers from the set of integer, you also get back integer. So in this case, we will say the binary operation here with the set given is a valid binary operation. Okay? Now, when it will be not valid? If, let's say, I still use back the same set of integer, but now I change it to divide. If I take any 2 integers and I divide them together, let's say I have 3 and 4, 3 divides 4, what is the answer I get? 0.75. Can I say this one belongs to the set of integer or not? Cannot, isn't it? So, if you do with the operator given and from the elements of the set given, the answer you get is not belong back to the original set, then in this case you will say this binary operation is not valid. Understand? Okay, so you must make sure after the operator given, the result you get must be from the element of the set given also. Okay? Now, this is the example for the first example here. You can just write any 2 integer like I give you just now. So you can say 2 and 3 belongs to the integer, and then after that you add up these 2. It is also belongs to the integer, right? Now, another term that we will say for the valid binary operation is clause. You will say that this binary operation is clause under the operation of class. Clause. C-L-O-S-E-D. Okay? So we can also say that the set of integer is clause under the operation of class. Here, explanation. Now, second example, divide is not a valid binary operation on the integer. So this is just the example that I gave you just now. So we have let 2 and 3 also belongs to the integer, but after you divide 2 divides 3, it will not belongs to integer anymore. So that's why we will say divide is not a valid binary operation. Yeah? In that case, it is, but you need to make sure all can be like this. Then only you can say valid. As long as you can find one case that is not, which is a counter example, then it cannot be a valid binary operation already. Understand? You cannot say all are true, right? Of course, some of them will be true. The integer depends on what is the integer you choose. But of course, we want to show the one that is false, that is not correct, to say that it is not valid. If you want to show valid, you cannot show like this, you know. Just now I show you 2 plus 3 is 5, only one example. Actually, we cannot show like that to say that it is valid. This one I give you like this to make you understand first. Next time, when you want to do your tutorial, you want to show that the binary operation is valid, right? How do you want to show this? You need to use a general form. Instead of 2 and 3, you need to say, for all the x and y which belongs to the integer, x plus y will belongs to integer also. Then only you can say that the integer with the operator plus is a valid binary operation. Remember, So in the tutorial question, when the binary operation is valid, don't use 2 specific numbers. Use a general form for the set given. To represent any integer we substitute in, also we can get it is valid. Because if you only show 2 numbers, only these 2 you show it is true. What happened to the others? Right? So we need to prove all are true for any x and y, which are the integer. And if you want to prove it is not valid, then you just find one counter example is enough. You can let your x becomes what, let your y becomes what. Then you divide it, you get not integer. Then you can conclude it is not valid. Understand? Now, example 3, union. How about union? Union on this PS. PS is what? Remember what is PS? You have learned set before, right? So, under the set, what is PS? Power? Power? Power set. What is power set? Order. You return to who already? Power set means all the subset under the set S, right? Okay. Now, if we want to determine whether the union is a binary operation of this or not, do you think any element from the set S, you union it, you will get back the element from S? Yes or no? Okay, for any A and B, this one we put it belongs to the power set S, subset. Then A union B, it will also belongs to the power set S. So this is a valid binary operation also. As long as we write like this, then you will know that a PS and the union is a valid binary operation. I write like this, binary binary operation. You don't follow me? Okay. Next example 4. Now, if let's say now the set given is 0 and 1, and they give you the N and O table, so you need to determine whether this is a valid or not. So what we need to do is complete this table and see whether the answer we get here also from 0 and 1 or not. Do you think it will be 0 and 1? What is 0 and 0? Huh? 0. 0 and 1? 1, 0? 1, 1? Okay, so this answer belongs to A, right? How about O? 0, 0? 0, 1? 1, 0? 1, 1? Okay, so you can see that all the answer here also belongs to the set A. This one also belongs to the set A. That means the connective N and O also be a valid binary operation under the set A. Now, when we represent the binary operation, right, we will always write it as an asterisk. When you put the asterisk like this, sometimes you will see x asterisk y. This means that it is the product of x and y. Under this, it means the operation in between x and y. What is the operation? It will be given by the question. Either it is the operator plus, operator minus, divide, multiply, union, intersection, and so on. So the operator will be given to you. You no need to write x asterisk y. Sometimes we look at the example here. If you follow this, the asterisk it should be n. What is n? X and y. Represent the operator that we have. Okay. So when you want to pronounce the binary operation, you can just say it is the product of x and y. Okay, so it depends on what is the operator we have. Now, next one you need to know is associative, and I believe you have learned associative before. You still remember what is associative or not? Not remember. How is associative? How many terms we must have for associative? How many terms we must have if associative? X, Y, Z. If I do these two first, the answer must be the same way I do the Y and Z first, right? Remember associative? The sequence we do follow the bracket. If the bracket is in front, we do the front part first, and then if the bracket is at the back, we will do the back first. Now, finally, the answer of these two should be the same if follow associative property. So, if these two are the same answer, actually, you don't put the bracket also doesn't matter. The easiest example is what? What is the operator we can say it is associative? Any example? Operator? What is the operator that can be associative? Meaning that no matter which part we do first, we will still get the same answer. Give me one example of operator. plus, okay? So if let's say I put x plus y bracket plus z, this answer will be the same with x plus y plus z bracket, right? Agree? Any others example beside plus? Yeah? Multiply. Okay? So x multiply y multiply z is the same with x multiply y bracket multiply z. This answer must be the same, no matter which part we do first. So this is for associative. Huh? Another operator that we have beside associative, this is also you learned before, commutative. Now, if associative involves 3 terms, then commutative only involves 2 terms. xy equal to yx. Okay, change the position only. So you see here, it is commutative if x asterisk y equal to y asterisk x. It depends on what is the operator given. What is the example for the operator that is commutative? X plus y equal to y plus x. Agree? Then multiply also the same. A multiply B equal to B multiply A. Any other operator? Can I say x minus y equal to y minus x? Cannot. Okay. So we give the example that can be equal one for commutative. Can I say A union B equal to B union A? Can this be the same? Yes. Can I say P and Q is equivalent to Q and P? Yes? Can, right? Okay. So these are some of the examples that it will show whether you exchange your position, they are still the same. Then we can say that this is commutative. So next time when you do the commutative, you only need to involve two terms, x, y. And if you do the associative, you need to have 3 terms. The 3 terms here, it depends whether you want to get x, y, z or x, y, y. No problem. As long as you have 3 terms, then you need to show they are the same answer to show that they are associative. Okay? So now this is the introduction. I think I will stop at this part before we go to semigroup. Introduction of semigroup for this chapter. You need to know this term first. Okay? So the term that you have learned now